Hi, this is the third multiple choice question on the AP Physics C extra credit questions. So here we're given an Atwood machine, and the first thing we know from our physics fact that we should do, we see an Atwood machine is to draw a free body diagram. So free body diagrams include label arrows representing each force and a list of the forces and the agent applying the force. For this question, we also need to know that weight force is equal to mg. And then lastly, we need to follow our two body problems rules. So for these, we're going to need to utilize net force equals mass times acceleration, draw one free body diagram per object, and one rope equals one tension. So with these physics facts, we can start our problem and we can draw our free body diagrams. So for block A, our free body diagram, we have our weight force, which is mg, pushing down, and going up would be our tension force. And our tension force would be larger than our weight force, hence a larger arrow, because when the blocks are released from rest, block A shoots up. And then for block B, our FBD, looks something like this. It should be reversed. It should have a larger weight force, and this weight force would be 2 mg, because that's the mass. And then its tension force would be smaller, because block B, when they're released, goes downward. So net force is going downward. So force of tension. So now we can, from these FBDs, and there's no horizontal movement, so that's irrelevant. So from these FBDs, we can set up a system of equations. So for block A, our sum of forces, which is stuff that makes it go minus stuff that makes it stop. So the stuff making it go would be the tension force, minus the stuff making it stop would be mg. And then that would be equal to ma. For block B, we would do 2 mg, the stuff making it go, minus our tension force, the stuff making it stop. That equals 2 ma. Okay, so now from this, we can add the 2. And when we add the 2, our tensions cross out, and we're left with mg equals 3 ma. Our m's cancel, and we're left with 3a equals g. A equals g over 3. So we gotta store that for later, and because now we need to find the relationship between that acceleration and the acceleration if the mass of block B is doubled. So our equations would stay the same. Our equation for A would be exactly the same. Ft minus mg equals ma. And then for block B, our equation would be similar, except we're doubling the mass of block B. So instead of 2 mg, it would be 4 mg. And the tension force is the same. And then it would be 4 ma. Okay. And then, so now we add these two. Tension's going to cancel just like before. We're going to get 3 mg equals 5 MA. Our M's will cancel. Get 5A equals 3G. A equals 3/5 G. So this, I should say A2. Our second, our A when the mass of B is doubled would be 3/5 G. And then our A1 was 1/3 G. So now the relationship between the two, the new acceleration, the question asks how many times more is A2 than A1. So we just do 3/5 divided by 1/3. Because if the G's would, they're in both expressions. So they become essentially irrelevant. And then 3/5 divided by 1/3 would be 9/5. So our answer would be 9/5 A. And that would be this choice here. And that's the right answer. So there you go. Thank you.